All right. Physicist friends, let me have your attention, please. Hopefully you saw. Is that working? Now you can kind of hear me up there, maybe? Right, that's kind of cool. Right? New technology, pretty exciting. We've actually had it for like since we got here. I just haven't ever tried it, and I kind of like it. Do you guys like it, or is it freaking you out? Kind of like sound like I'm standing up there. I'm going to leave it on for today. We'll see kind of how things go. Some people have a little bit of a hard time hearing, and even with my like super teacher voice, it's a little bit easier for them to hear, which is why I'm doing that. If it totally is freaking you out and we decide as a group that we don't need to do it, then that's okay with me too. But we'll try it for a couple of days and see how it goes. It is weird to me too because I like can hear my voice and you know how that goes, right? But anyway, all right. So hopefully you put your lab into the basket. If you haven't for whatever reason, go ahead and put it away for now. Or like if it's done, go ahead and put it in the basket. Sorry. If it's not done, put it away for now. We'll talk about it later. I just don't want it to be distracting you from the rest of what we're doing today. So quick announcement first. I don't know, I'm hoping that you all were able to make it to the Club and Activities Fair over lunch the last couple of days. I forgot to remind you yesterday, and I'm really sorry about that. That was my bad. But I'm hoping that you made it. I want to make a specific invitation to you to join the Liberty High Robotics team. I'm one of the co-sponsors of that team. It's super fun. It's a small group of people. We build a robot, and then we take it to meets and we run it through what they call their games, and so there are like specific tasks that we try and build our robot to do. So we build a robot, we program the robot, and so we've got some people that are on each of those kind of teams, and then some people that are just doing things like outreach and documentation. So if any of those things sound of interest to you, we would love to have you. You don't have to know anything about building a robot or programming a robot or anything. We'll get you hooked up. It'll be good. If that sounds interesting to you, we would love to have you. We meet on Mondays and Tuesdays. Friends, I really don't like to talk over other people talking. So if that spot is going to be too distracting for you, then find a different place to sit. Okay, that goes for everybody. Okay, it's really frustrating to me. Okay, thanks. The robotics team meets Mondays and Tuesdays from about 4 to 5-ish in the makerspace throughout the season, and our season usually ends in January, February. And our first meeting is next Tuesday. So if that's of interest to you, we would love to have you. Like I said, you don't have to have any experience. And if you have something else going on next Tuesday, because I know there are a lot of groups just getting started, let me know and we can get you hooked up with information, even if that meeting doesn't fit in your schedule. If robotics isn't the thing that sounds fascinating to you, but there's something else that might, there are lots of clubs that are really fantastic at Liberty. I would strongly encourage you to think about joining something more, something different besides just doing school or just doing school in a sport. Why? Because it helps you to feel more connected to the school. It keeps you, kind of engaged. It also, this is not why you should join a club, but it doesn't hurt. It looks really, really good on a college application, right? Like that's, again, not the reason that you should do something, but it doesn't hurt anything. I'm not saying that you need a laundry list like of 17 activities that you do, but if there's something that may spark something in you that you find a passion for, that can be, well, it's great to just have it listed. It also can be great for an essay, things like that, an interview if you go to interview at a school. So just think about that. Like that might be a good opportunity to take something on that maybe you've never done before. Try something new, right? Nothing wrong with that. So anyway, that's my spiel. Join something, do something, it's good. Okay, so that's the first little piece. Today we're going to finish going over the math review sheet. We're going to work on a lab, so we're not going to spend a lot of time on the purple sheet, but we'll spend enough so that we can get there. Homework for tonight is going to be to finish the lab analysis from what we're going to do today. And any of the book homework questions that you had from last night, I'm happy we'll go over those tomorrow. Does that make sense? So if you have anything that's kind of residual or doesn't make sense, I'm really happy to help you with that. Did everybody find where the questions were? I know that the bell was like ringing right at the, as we were talking about that. In the back of the chapter, right, there are questions and problems. Does this make sense to everybody? You may have issues or concerns. If it comes up or if you do have questions, let me know. Okay. Purple sheet. So pull that out if you don't have it out already. Yesterday we went through, if I'm remembering correctly, we made it through F at least. But I don't remember. Did we make it through any more of those?
We did G.
We did G as well? Okay. So I went ahead and wrote down solutions for the rest. I've got them saved. And so if there are ones that you want to talk about, I am super happy to do that. But so we need H, So I'll do H-I-J there so you can take a look. These are my notes. I was just writing these down really fast before you guys came in, so it's possible that I made a mistake. You guys will know that about me very quickly if you haven't figured it out already. Humans make mistakes, and I am certainly a human. So we're all in this together. You got to help me out and let me know if there's something wrong. But I think that H, I, and J are correct per my work. Are there any of those three that you would like to go through? Yeah. G, for sure. So G, that one, let's take a look. One thing that's kind of hard to see on the copy that I gave you because it was so darn tiny is that this is an I, so I want to make sure that you saw that because if it looks like a 1, then that may have thrown things off. So it's this funny letter that's a Greek letter. You're not familiar with it, you're not sure what it is. So one approach to that is just to copy down whatever it says, right? Like, yeah, sure. But if you want to know, the Greek alphabet is up here in orange. And it's kind of, like you had in kindergarten, you had the alphabet in Roman letters, and so this is the Greek alphabet. We will be exposed to and hang out with many of those letters throughout the year. Mu is the one that, the capital one looks very similar to a capital M. In fact, it's the same, but in Greek, it's called mu, not M. And the little one is the one we use more often. And so it looks like a little U with a tail at the beginning as well, okay? And the way you say it is mu, kind of like a little cat says mew, right? So I want you to say it with me, mu. Yeah, that's beautiful. It's sometimes intimidating to say a new letter or a new thing if you don't know what it is. So that's mu, and this is mu naught, which is what that is, right? Times I over 2 pi r. That's how it's written there. So we need to solve it for r, which means we're going to multiply by r on both sides, and then divide by b. But I'm glad you asked because I wanted to talk about mu, so it worked out. So thank you so much for that. Yeah. Questions on any of these other ones here? This one I want to make sure is making sense to you. Sines, cosines, all that good stuff, right? Your trig relationships. Sine is not a variable, but it is a function. So to undo sine, you're going to do the inverse of sine. That's marked with sine to the -1. Is that looking familiar to people? Is that okay? Fantastic. I'm going to go ahead and scroll down if that's okay. So take a look there at K and L if you haven't checked those. And again, I don't know if those are exactly what were written on the boards from yesterday. Just in looking for time, I just wanted to make sure we're good. How'd we do? Any of those that you want to go through? Yeah. L. For sure. I'm glad you asked. I was hoping somebody would ask about that one, so let's do it. So L is a little bit funny, and I told you yesterday, I think, that we're going to see most of these things this year. Actually, this one we won't see. We don't actually use that equation in AP Physics 1. We just do it we used to do it in AP Physics B. But that doesn't mean that it's not good math skills to have. So we're trying to solve for S sub I. So that thing is living down in the denominator here. Okay. So we're going to just kind of peel away things, try and get S sub I all by itself. So the first thing I'm going to do is to subtract the 1 over S sub O from both sides. So that gives me 1 over F minus 1 over S sub O equals 1 over S sub I. And now the trouble is that I've got S sub I, it's by itself, but it's not really, like it's in the denominator, right? Can you just flip it? Is that allowed? Sometimes people want to. It seems like you should be able to, right? But that doesn't really work. It doesn't. Do you want me to prove to you that it doesn't really work? Or are you okay? You believe that it? Yeah. Okay. I just want to make sure. Somebody's like, I think it would. No, you wouldn't. You can plug in any fractional numbers in there to make sure, but I promised you that it does not work. So we need to get. How do you get this out of it? You have to multiply on both sides and divide, right? So you're gonna put the rest of this stuff all in the denominator over here. Right, that's where it's going to live because you're going to multiply by S sub I and then divide by the whole mess of that stuff. That's where it's going to go. Does that kind of make sense?
Can you do that all?
Yeah, for sure. So I'm going to multiply by S sub I. So I've got S sub I times this big disgusting mess. right? And then I want S sub I all by itself, which means I need to divide by the big disgustingness. Yeah, yeah. So S sub I is equal to, so this is just 1 on this side right now. 1 over F minus 1 over S sub O. Yeah. Thank you for asking. Appreciate that. Any other questions on that side of the purple sheet? Okay, cool. This really is just getting into good practice for being able to solve things. That's a lot of what we do. There is math in this, and there is, plugging in numbers, but so much of what we're going to do in AP Physics 1 is really just manipulating equations. And so your comfort level with this is important, okay? But not to say that if you aren't comfortable right now that you won't be. We'll get you there. All right, for the conversions, I just typed them out because it seemed faster than writing it out for each one. Again, I did this by hand, and I don't have a key. I just stole this sheet. So check your answers with my answers. See if they match. I'm very happy to go through any of them that you would like to. But take a look and see how we did, and then we can go through, like I said, whatever you'd like. That, yes, there should be a negative sign there. It's the danger of typing things out. Yeah?
Do we always default to writing in scientific notation?
Good question. Should you always default to writing in scientific notation? So the short answer is it doesn't really matter. I want you to be comfortable with scientific notation such that if you see something that's written in scientific notation, you know how to deal with it. I think it's cleaner to write in scientific notation, but especially if you have something that's got like an exponent that's higher than like 2 or 3 maybe, then I would say yes, write in scientific notation. But if you have like 270 and you want to write just as 270, that's totally fine. Does that make sense? And I'm not going to count it wrong. It's just easier to deal with usually. Yeah. All right. So others of these that you guys want to go over? Yeah. For sure. Yeah, we're going to go over 4. Oh, I'm on freezing. Sorry. There you go. All right, number 4. Here it comes. There it is. Okay. So 85 centimeters per minute. And we're trying to get it into meters per second. So the approach for this, you can do this lots of different ways. And we actually had a meeting this summer with the chemistry people and the physics people to talk about conversions and how we teach it. And there are like 7 different ways that are like all normally accepted to teach it. This is the way that makes the best sense in my head, and this is the way that I usually teach it. But if you have a different way to do it and it works for you, that's awesome. Does that make sense? But this is the way that I'm going to set it up. So I'm going to write 85 centimeters per minute. I'm going to make sure that I write this as a fraction with a numerator and a denominator, and then same thing over here, and I'm going to leave a bunch of space in the middle to do the conversion. So let's go from centimeters to meters first. The process in my head goes, which one's bigger, a meter or a centimeter? Meter. How many centimeters are there in a meter? 100. 100. So I'm going to multiply by a form of 1, where 100 centimeters is equal to a meter. Do I want the centimeters on the top or the bottom? One on the bottom. Why? You got it. So I'm going to say 1 meter is equal to 100 centimeters. Centimeters go away. And then I'm not quite there yet. I still need to get it into seconds from minutes. So I'm going to multiply again by a factor of 1, getting from minutes to seconds. Which one's bigger, a minute or a second? A minute. How many seconds are in a minute? 60. So I'm going to say 1 minute is 60 seconds. Minutes are going to cancel. And then I'm going to take 85 divided by 100 divided by 60. That'll give me a value, whatever that was, 1.4 times 10 to the negative 2. Does that get you where you need to go? Yeah. Awesome. Thanks for asking. Are there any others of them that you would like to go through? If there's one that comes up later that you're like, wow, I totally didn't get that, or you just don't want to say it out loud right now, just let me know. We can talk about it whenever you're comfortable with it. Okay? All right. So at this point, I'm going to assume that this stuff and this stuff, it makes sense to you, And if not, that you'll come and talk to me so that we can feel better about it, so we can move forward. We're gonna go ahead and move on and start a lab today, okay? I'm gonna talk you through a couple of quick things in the lab here first, then I'll hand it out and we'll get started. I'm gonna hand it to you so you can write on them as we go. All right, you're welcome. So we got these really cute little buggies. They're super cute, right? You can order them on, I don't know, like Amazon or whatever too, but I just think they're adorable. They're adorable for a few reasons. I mean, they're cute. They've got little stickers on them, so that makes it pretty adorable. They also, when you flip it on, their lights blink, right? Like, how cute is that? Okay, so anyway, that's your buggy. This is what you're gonna deal with. So a few things about buggies. Buggies are not to be run on tables because if it gets to the edge of the table, then it's some projectile motion. Projectile motion is not what we're studying yet. We'll get there, and we will launch things, but not buggies because the buggies will not land well. Okay. So you're gonna run the buggies on the floor. Okay. So that's one thing to remember about them. So this is your buggy. You want to be careful with them. Don't let them run away. Sometimes, especially my smartest students will forget, they'll like take data, and then just like start writing things down and the buggy will just keep going. Like it's really pretty adorable. But like make sure that somebody's there to catch the buggy and turn it off, just for sanity's sake for everybody. So these are the buggies that we're going to use. So it says that we're going to make some observations. We're going to turn on the buggy and watch its motion. We're going to write down some things. So in here, you're going to write down some things. This says the lab will not require a full lab write-up. Don't want to do that right now. We're going to record observations and data on paper, one per group, which is totally easy, totally fine. You can handle that. Everyone's handwriting and ideas obviously included. So it's not like one scribe, but you're going to have people doing that as well. Then you're going to follow these instructions. All of the equipment that you need, I think, is over on that lab table, but if there's something I missed, let me know. Okay, you're going to take some observations, you're going to make some measurements, and do some data collection. Then on the back of your sheet, each person, I want to just point this out to you so you see, you want to circle that or highlight it or something so you don't miss it. Each person individually is going to produce a graph on graph paper. On graph paper. I never, ever, ever want a graph from any of you on lined paper or on blank paper, okay? A lot of people try to do that, but if you don't have lines going this way, then it's really hard to try and figure out where something's gonna go. My graph paper lives right here in this drawer labeled graph paper, okay? And if you're at home and you need a piece of graph paper, you can Google free graph paper or printable graph paper or even just graph paper, and it will pop up and then you just print it and you're good to go. That's where I got that. I just Googled it and I printed it and copied it a bunch. Okay, so you can totally do that too. You too can have your own graph paper. Yes, you can. Okay, you're going to graph your graph on graph paper. You're going to draw a best fit line. If you're not sure what that means, talk to your group. And if you're not sure if your group does, sure, then ask me. I'll help you out. I'm going to find a slope. Oh, the slope. We haven't done slopes yet. Yeah, you got this. And then you're going to answer some questions. Okay? Seem like a doable thing? Okay. We're going to do groups of 3. I think that will work. And I want you, here's your one task, is that you need to work with people that are not at the table you're sitting with. Okay? So find some new people to work with. Go ahead and get started. And have fun.